Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not have this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 246. 246, and today is our lesson number 157. The same video you will also find in my playlist of geometry videos under day number 54. And if you're weak in geometry and if you want to get some more practice on geometry problems, that's the place to go. Start with day number 1 and make sure you go through the series in the proper sequence, and you will get something out of it. Problem number 21, part B. We are told that f of x equals 100 minus 900x. So in our job, we are told that for this particular function, we have to tell them what the domain is. We have to describe what the graph looks like. In other words, plot it, and also figure out its x and y intercepts. So there are 4 or 5 things that we have to do. And while we are at it, we will also figure out the slope. This, as you can tell, is a linear function. This is a linear function. How do we know it's a linear function? Because x is raised to the first power. Had it been x raised to second power, it would have been quadratic function. Had it been x raised to third power, it would have been cubic function, and so on and so forth. In the GRE, you will never see x raised to third power. X raised to second power is about the limit, which is a quadratic equation, which do appear in the exam. But this is a linear function. And since it's a linear function, the graph is going to be a straight line. A straight line. So that's our function here. Y equals f of x, which is 100 minus 900x. Y equals f of x. Y equals f of x, because that's what it means. F of x means value of the function at a given value of this function for a given value of x. F of x means value of this function for a given value of x. The value of the function for a given value of x is the y value. That's what y is. Y equals that quantity. Let's first find out its intercept. Y-intercept is where the line cuts the y-axis, which is where x is equal to 0. So we put in x equal to 0 in this equation and we'll find our y-intercept. So y equals, we are told y equals 100 minus 900 times x. We put in x equal to 0 in this equation. 900 times 0 is 0, so the y-intercept is equals to 100. The place where it cuts the y-axis is going to be at 100. Let's find out its x-intercept. X-intercept is where it cuts the x-axis. I'm not going to write everything down. X-intercept is where it cuts the x-axis, and that's where y is equal to 0. Is where y is equal to 0. Because if it cuts the x-axis, there is no y, there is no height. So we plug in, here's our equation, y equals 100 minus 900x. Let's do it in the top. There's no reason why we should do it so low. It's a linear function. The graph is going to be a straight line. y equals to 100 minus 900x. We plug in y equal to 0 and we solve for x. Bring the 900x to this side by adding 900x to both sides. 900x equals 100. Divide both sides by 900 and you find that x equals 1 over 9. That is your y-intercept. Let's plot it, shall we? Let's plot it. Let's plot it here. So we know, now as I explained to you before many times in the past, when you're plotting a graph, the scale on the x-axis and the y-axis do not need to be the same. For example, from here to here, I can tell you that from here to here is 1 inch, this is 2 inches. So here, on x-axis I'm measuring in inches, and on the y-axis I'm measuring in miles. So this distance represents 1 mile, but that represents only 1 inch. The scale on the x and the y-axis do not need to be the same. The scale has to be consistent along a given axis. Along a given axis. In other words, if this is 1 and 2, this cannot be 5 and this cannot be 20. That would be silly. It cannot be 5 from here to here if this is 1 over from here to here. So the scale has to be consistent over a given axis, but scales do not have to be the same over x and y axis. Of course they cannot be the same. As you can clearly see here we only have 1/9 and here we have 100. We're not going to, it'd be silly, the graph is going to look silly. So here we go. When y is 0, x is, or right here, when y is 0, x equals 1/9. So when y is 0 along x-axis, x equals 1/9. So here's my 1/9. X equals 1/9 when y is 0. So from here, I'm saying that from here to here is 1/9. 1/9 of a unit. And then for y-intercept, x is equal to 0 because we are on y-axis. When x is equal to 0, we found that y is 100. Y is 100. So let's plot 100. So this point right here, the intercept of this point are, the coordinates of this point are 0 and 100. That's it. That's what our graph looks like. Our graph is going to look like that's it. That's the graph of the line. What is the slope of this line? Even though they do not ask for a slope, what is the slope of the line? Well, the slope of the line is slope equals change in y over change in x. If we go from here to here, from 0 to 100, y goes up by 100. And as a result, as we move from point A to point B, what happens to the value of the x? The value of the x goes down. It goes down from 1/9. So, well, if you like, we can take our time. It's y2 minus y1 over x2 minus x1. y2 is 100 minus y1, which is 0. x2 is 0 minus x1 is 19. And we end up with 100 slope is, that's right, 100 over negative 19, which is same as negative 900. Slope is negative 900. What does it tell us? What does it tell us? It tells us that the slope of 900, slope of negative 900 tells us that for every, let's put it up here. it tells us that for every 1 unit increase, x, y decreases by 900 units. Notice the relationship is reversed. When for every one unit increase in x, if x goes up by 1 unit, y goes down by 900 units. And if x goes down by 1 unit, y increases by 900 units. If x goes up by 1, y goes down by 900. If x goes down by 1, y goes up by 900. Which is what negative slope means. Negative slope means that they move in the opposite direction. If one goes up, the other one goes down. That's what it means. What values that x can take here? In this function, x can take, in this function, x can be whatever the hell it wants to be. X can be whatever the hell it wants to be. What's the translation in mathematical? This is the English language. What's the translation in mathematics language? In the language of mathematics, the translation would be what's the translation? Translation means, what's the translation? Translation is domain equals set of all real numbers. That's how you say in the language of mathematics. If somebody tells you that domain for this function is a set of all real numbers, if somebody comes up to you and tells you that this for this particular function, domain is a set of all real numbers, what they told you just now is that you can have any value that you want for x. There are absolutely no limits on it. X can be positive, negative, fraction, rational, irrational, you name it. It can be any value it wants to be as long as it's a real number. Now, this part about the real number, we're not going to make too much fuss about it. I'm not going to go there because it's not required for the GRE. But the mathematicians live in two worlds. They live in the world of real numbers, and they also live in the world of what they call imaginary numbers, which we do not have to worry about what they are. We're not going to deal with it. They do not appear on the exam. Don't worry about it because you will not deal with it in your real life. Trust me, take it from me. I tried it one time. I went to my bank to pay my mortgage with a bag full of Iotas, and they didn't take them. And for those of you who understand what I just said, you will understand what I meant. The imaginary numbers, the word iota is not used just now. I use it as it is used in English language. The term iota is also a term in mathematics, which has to do something to do with imaginary numbers. We won't go there. So that's it. That's all it was. They want us to find. Let's start from the very beginning. They gave us the function. The function was f of x equals 100 minus 900x. Our first job is to tell them what sort of shape this curve has, this graph has. This graph, as we can tell, is this, because it's the first power, it's a straight, it's a linear function. It's a straight line. It's not going to curve. It's a straight line. It's not a parabola. It's not a circle. It's not any kind of funny business, it's just a straight line. The next job that we have to do is tell the intercept. Well, when x is equal to 0, 900 times 0 is 0, y is equal to 100. So when x is 0, that's your y-intercept. Y-intercept is 100, which means it cuts the y-axis at 0, 100. To find the x-intercept, we said y equal to 0. When y is equal to 0, we bring the 900 over there. 900 x equals 100, therefore x equals 100 over 900, which is 1 over 9. 1 over 9 and 0. You cannot read it anymore, I'm going to write it here. 1 over 9 and 0. That's your x-intercept. What is the slope of this function? Slope of this function we found was negative 900, which tells us that for every 1 unit increase in x, the y will drop by 900 units, and vice versa. What is the domain of this function? In other words, what values can x take in this function? Well, there are no restrictions here. X, you can put in any number that you want for x. Any number whatsoever. You can put in a fraction, a positive, a negative, a whole number, radical, whatever you want. It doesn't matter. Whatever number that you put in, as long as it's a real number, you can multiply it by 900 and take it away from 100. That's your y going to be. Since x can take any value it wants to be, therefore we say the domain is a set of all real numbers. That's all. That's it. We're done. I'm going into too much details for the benefit of those people that who are not familiar with this terminology and so forth. We'll do tomorrow we'll do part C. Part C deals with the concept of parabola, which is going to be a lot more fun and it's going to be very time consuming. I'll see you tomorrow, okay? Bye.